number 2 from the packet. Angle. That angle they labeled 3x. Is it inside or outside the circle? Here we go. Let's start it off. 26. Is this inside or outside the circle? It's outside. So I find any angle outside the circle by taking half of 2 arcs subtracted. What's the major arc up here first? What's the major arc? 7. What's the major arc? 11x minus 2. And now here's where you may have been a little confused. What is the minor arc? What is the minor arc? 4x plus 15. But if I write this, you're not subtracting the minor arc. All you're subtracting is 4x. You need to subtract, take a look, the entire minor arc. What am I trying to get at? What do you have to do with this negative? Distribute it through. Okay? When you just write minus 4x plus 15, the only thing you guys are subtracting are 4x. It's minus the entire minor arc, which is 4x plus 15. Now when you rewrite it, 11x minus 2 minus 4x, now it's going to be minus 15, and now you'll get a positive answer out. All right, instead of the negative 13 or whatever you guys ended up getting out, which you know it couldn't be negative because you can't have a negative angle measure there. Okay, so everyone see how that one worked there? A little bit tricky, I know, but you have to subtract the entire minor arc, whatever it is, subtract the entire thing. So distribute the negative all the way through. All right, let's go bookwork now. Ask as many questions as you want, because if I get to the stuff today, I get to it. If I don't, that's the way it is. Evan, go. 20, everybody. Okay, here's the deal with 20. Take a look. It wants me to find arc JM. All right, arc. I'm assuming that's going to be this arc JM because this arc going this way. I don't know. That's a good question. They should have put a. Was that one of the problems? You didn't know which JM or? Okay, so you assumed it was this one right here? Yeah. Okay, that's what I would assume too. So how do I find it? Evan, ready? Where's that 47? Outside. So how did I find it? I took half, adding or subtracting the arcs? Subtracting. What's the major arc? It's the one you're trying to find. Right? You agree? The major arc is right here. That's the one we're asked to find. So I'm just going to call it x minus the minor arc. 111. So just like I've always been doing here, I'm going to multiply both sides by 2. I get 94 equals x minus 11. Add your 11 over, and you end up with that 205. Okay. Next. What do you got, Skylar? Jewelry, got it. You were trying to find this arc right here, x, and it told you x. Never mind, you're trying to find y. That's 260 degrees. Is that angle y I'm asked to find inside or outside? Outside, so it's going to be half of 2 arcs subtracted. The major arc, already 260. Minor arc, not given to me, but if that's 260 and the minor arc is the rest of the circle, I could do 360 minus 260, which would give me 100. So now I take half of 160, and that's where that answer of 80 degrees came from on the outside. Okay, good. They didn't have this here?
There was a Y, but there wasn't an arrow.
Really?
Yes, so I just
That's interesting. Okay. They just had a Y floating? Okay. Other questions? Yes, Jack? Sure. Okay, 18, find angle A. Where's angle A located? Outside, so it's got to be equal to half of, here we go, the major arc. It's not labeled, but the minor one's 99, and the major one's the rest of it. So how do you find the major one? 360 minus 99, whatever that is, minus, what's the minor one? There you go. And I'm on my way. Okay, so you just have to find that major arc by doing 360 minus 99. Others? Go ahead, Rose. 10. Okay, JMK, this angle right here. Inside or outside? Inside. Not a central, not an inscribe, but it is a floater angle. Okay. Well, it's going to be a little tough because, let's see, for floater angle, it should have been this arc plus this arc times 1/2, right? But I have no idea what those arcs are. These aren't diameters, so I'm a little stuck there. So instead of finding JMK, how about I find the one right next to it, which is also a floater angle. So this angle right here, I can find by doing 1/2 of 79. Since it's floater, I'm going to add, plus its vertical angles arc, 77. That'll get me that angle, and then how can I get the one that I was asked for?
I found that angle.
Subtract it from 180. Okay? All right, so you're right. There's no way I can find JMK using my floater angle rules, but I can find the angle next to it and then subtract it from 180. More questions? Anything else here? Tomorrow's quiz. Before I get to quiz 1. Did I show you yesterday the setup or no? Nope? Okay, good. Here's the setup. Tomorrow's quiz. First page, second page, whatever. All the multiple choices. Multiple choice. There will be a review question, just like I promised you. Topic unknown, but we've at least gone over the topic. I'm not just going to throw out a topic we have not at least reviewed out of all those review questions we've done. The rest of the multiple choice will be coming from quiz 1 topics. All right, so that's what all the multiple choice will be tomorrow. One review question and quiz 1 topic. So we're talking circumference, arc length, radians. All right, all multiple choice for you. And then the non-multiple choice where you have to show your work, we're going to have a couple questions regarding tangent lines. So make sure you know your 2 theorems on tangents, which we can go over right now. Anybody know the 2 theorems on tangents? Go 1 theorem, Madeline. We got to know for tomorrow. What's that line called when I draw it from the radius? Radius drawn to the point of tangency, bless you, is perpendicular to the tangent. And there was another one. Rose? Two tangents meeting at the same external point are congruent. And then there will be 2 big circle questions. Everyone know what I mean by that? Those are the big dogs we've been working on at the end of class for the last couple days. Parts A, B, C, D, E, F. Might be inscribed, might be floater, might be on the outside. All right, so that's what it's going to be made up of tomorrow. I'm telling you right off the bat what's going on. I have created a packet of 54 big circle questions with answers. If anybody wants to stop by and get some of you have already done so. I've also moved around because I know how tough quiz 1 went. I've also moved around my schedule, and I will be here after school today, just for you guys. Okay, so if you want to take advantage of that, I will be after school today. Before we get to quiz 1, any questions? Check out your assignment sheet before we get to quiz 1 or wherever you write your assignments down. Just so you know how important I'm taking this quiz tomorrow. Tonight's homework and the review problems I assigned on Friday are all due on Monday. Okay, so if you don't want to do them tonight and want to focus on quiz 2, I'd recommend that then. Okay, so tonight's book or packet work tonight. Tonight's packet work and tomorrow night's review problems are all due on Monday.
So tonight's work isn't going to be on
No. Nope. Today's stuff is not. It ends yesterday. When we found this angle on the outside of the circle, that's where it ends with the big circle questions. Yep, what we do today, what we get to today, if we get to it, not on there. All right, so there you go. I'm telling you what's on there. All right, and you know how tough quiz 1 was for a couple of you. All right, speaking of quiz 1, let's go through most of those problems right now. Make sure you write the correct work down if you got it wrong, especially these first couple multiple choices. All right, for number 1, the correct answer was 4. And let me just go over why it was 4, and then I want to go over why these are actually correct. These are actually true. First of all, here's the problem you guys saw. You saw ACB was an inscribed angle. You saw 1/2. Oh, it's got to be true. But you didn't read it carefully enough. What is this saying? That the arc is equal to half the angle. But what's true? The angle is equal to half the arc. Okay, I think some of you just processed in your mind, I see a half, I see an inscribed angle, it's true. All right, but hey, remember, the arc, the angle is equal to half the arc. So I would need to put the 1/2 over with arc AB for it to be true. Let's go through. Why is this one true? Everyone take a look. ABC is what type of angle? ABC, what type of angle? At this point, hopefully we know. What type of angle, ABC? It's inscribed. And take a look where it's drawn to. What's this right here? A diameter. We have a theorem. Any inscribed angle drawn to a diameter is what type of angle? A right angle, which makes it a right triangle. So that is true. ABM is isosceles. Yeah, it is, because what's AM? Radii. What's BM? All radii in the same circle are congruent. It's isosceles. Finally, why is 3 true? BMC. Everyone take a look at your paper. BMC is what type of angle? Central. How do you find any central angle? It's always equal to its arc. BC, BMC, that's a central angle. That's its arc. So that's got to be true. Questions there? All right, let's keep moving. What's the relationship between arc EF and arc CD? All right. We were given OC is 4, OE is 6. And again, these may come up as multiple choice tomorrow. Arc length. Measure over 360 times pi diameter. Ready? EF. I do not know the arc, the measure of the arc. I don't know, but it doesn't matter in this case. What's the radius? What's the radius here? 6, right? So that means the diameter would be 12. Okay. So this is for arc EF. Okay, let's go to arc CD now. I still don't know the measure, but does it really matter? What do you know about the measure of CD and the measure of EF? It's always going to be the same. They're coming from the same central angle. So what is the only thing that changes in both formulas? What's the only thing that's going to change? The diameter or the radius. That's the only thing that's going to change. All right? The one radius is 6, the other is 4. So how the arc length is going to compare? 6 over 4. That's 1.5 times the length of it. Okay? This doesn't matter what you put here. It's going to be the same. It's going to be the same because they're coming from, they're coming from the same central angle. So this measure is going to be the same as that measure. All right? So it doesn't matter what you put here. They're the same. So the only thing that's going to matter is the radii that you plug in, which is 6 and 4. We okay on that one? Whew, 3 got me going big time. It's just because you didn't read it. You just didn't read it. You knew how to do it. Hey, what's 268? A to B to C. Not AC. A lot of people just plopped it right there, AC. No. Hey, A to B to C, 268. Meaning, how can you find arc AC now? How can I find arc AC? Andrew?
Find AC's arc.
Yep.
Distance and divide by 2.
Yep, because this is what type of angle? Inscribed. How can I find arc AC? Just do 360 minus 268. Divide by 2. Yep, you get your 46. All right. Okay, that was just a whole reading thing right there. Whew, and then we get to 6, which was the whole bike ordeal. Big Al, giving everybody problems as usual. That wasn't bad. That wasn't bad. Part C was bad. The bike wheeled around the ground for 50 inches. What angle in radians does the wheel rotate? That's your arc length right there. That it rotated 50 inches. Some people thought it was degrees or an angle measure. Nope. We're trying to find it in radians. Tomorrow, you have 2 formulas. Measure over 360 times pi d. And you also have theta equals S over R. Which one deals with radians? Which one deals with radians? Theta equals S over R. Anybody remember what S represented? Arc length. What's the arc length? 50. Up above, it said the diameter was 20, right? So what's my radius? 10. So theta equals 5 radians. Okay, 5 radians. If you use this formula, what's your answer in? Degrees. You could have said 50 equals x over 360 times pi times 20, and a lot of you did, and I think you got like 286 and change maybe. But then you had to convert it. How do you convert? Multiply it by pi over 180, and you could have left the pi in the answer if you wanted to. I would have accepted that. But if you did that out, it should have been pretty close to 5. Okay, so please, going into tomorrow, 2 formulas for arc length, 1 with radians, 1 with degrees tomorrow. Okay, 1 with radians, 1 with degrees. What else do you want me to go over here? I'm running out of time, but I'll take as long as needed here. If we need to go over something else. Again, hey, here's your front page tomorrow. Here's your multiple choice. It's going to come from here. Not exact questions, obviously, but these are the topics I'm pulling from tomorrow. All right, these are the topics for your multiple choice. All right. I think did I make it pretty clear what to expect tomorrow? And hopefully this made it clear on the difficulty of this unit, even though the class average, I think, was an 85. So it wasn't that bad, but a couple of you got to step it up. Questions, comments? Okay. So what I do right now, I just told Juliana, not on the quiz. We're going to start today. All right. What we're starting today, not on the quiz. Anything else you want to ask here? Because if you don't come after school today for any extra help, this will be it. Because tomorrow I'm just going to hand you the quiz when you come in. All right, no time for extra questions. I'm just going to hand you the quiz because there's no homework to go over. Okay. Why not start off today with a proof, right? All right, challenge time. Everyone see the proof statement? Where have any of you seen that type of proof statement before? In what previous unit? Can anybody dig deep? I've asked you to prove something like that before. What? Even if you can't tell me the unit, maybe you just remember the reason. What do you got, Saad? It was similar triangles. Nice. Anybody want to go in more detail? It was the similar triangle unit. Katie? Means and extremes, yeah. Yep. And before I could do that, Saad, right, I needed to prove triangle similar. I don't see any similar triangles up there, right? So can we make triangles up there to prove similar? So I have AE, I got that. I got BE, I got CE and DE drawn. Let's draw in two other chords that make it into triangles, AD and CB. Let's throw those chords up there. So let's prove them similar. Main way to prove triangle similar. Angle, angle. You and your group right now. Can you find me two pairs of angles? I know everybody can find one pair, but can you find another pair using a circle theorem? All right, discuss it with your group right now. I'm going to write the pair. I know everyone's going to write. I'm just going to write the vertical angles up now. Angle CEB congruent to angle AED. Talk it over here. Where's another pair? And why? And I'm going to, another hint, it's a circle theorem. Okay, what other pair did you and your group say were congruent up here? Here you go, 19, what other pair? Oh, perfect. How about 6, what other pair? So B and D? Yep. If anybody had C and A, leave it, that's true too. It's gonna be from the same reason. If you had angle C congruent to angle A. Why? Well, they're inscribed angles, so we'll start there. Inscribed angles drawn to the same arc are congruent. Nice job. Now you have two pairs of angles. Now you know the triangles are similar. Go ahead, write a similarity statement now. Triangle CBE similar to triangles ADE. Angle, angle. Katie mentioned before means and extremes. There's a step before that, though. There's a step in between the triangles being similar and the whole means and extremes being equal. Anybody remember that step? Or maybe just the reason. Heck, Madeline? CSSTP, yes. Corresponding sides of similar triangles are proportional. Anybody remember what I needed in the reason? Are proportional. Are proportional. I need a proportion, yeah. A proportion so that it's going to fit when I cross multiply, it'll fit my proof statement. So if I put AE first, where's BE going to go? It's got to go bottom right because I'm going to cross multiply. And then CE and DE can go anywhere in the remaining two spots. Now cross multiply, yep. Now I get to the end that AE times BE is equal to CE times DE. Anybody remember the actual state? It does involve means and extremes. Because remember, here's your means, here's your extremes. There we go, Frank and his new do. Product of the means, is that professional or homegrown? It's bad? Why not? You have to actually look decent, I know. Means equals product of the extremes. Didn't you tell him how short to go? problem. Okay.
Just talking to all the other guys that work with it. Just cut it all off.
Got to talk to the flow master next time. He'll tell you where to go. What to tell him. Other questions here? Okay, I didn't want you to just do a random proof because, hey, why don't we just do a proof to start off the day? What are CD and AB in the circle? What are CD and AB? They're chords. And when they intersect, you guys know how to find the floater angles, but now we're going to actually talk about how to find the lengths of the chords. When two chords intersect, the product of their segments are equal. So CE times ED will always be equal to EA times EB. All right, the product of their segments. So when two chords intersect, I multiply their two segments, and that'll be equal to the other two segments. And that is the theorem for today we're working with. Okay, so when two chords intersect, the product of their segments are equal. And I'll show you exactly what we mean in these next couple examples. So we are no longer talking about angles, we're talking about lengths now. All right, basic application on number one. Here we go, 5. Ready to help me out? Okay, do you see two chords there? Do they intersect? Name two segments on one of the chords that are formed. So 8, the product of 8 and 2.5, those two segments will be equal to the product of the two segments on the other chord, which are what, Malin? 2 and x. See, everyone, how this new theorem works. When you have two chords that intersect, the product of their segments are going to be equal to each other. All right, so I end up with 2x being equal to 16, 4, 20. X equals 10. We are right on how that one works. Next one. I'm going to need a stud for this one. Who's got 26? All right, let's go, Lauren. Ready? Do you see two chords in the diagram? Well, let me start there. Name one chord. The chord that's split up into? Okay, everyone see, here's chord number 1. I'm going to do it in pink. Do you see another chord in that diagram? The diameter. Remember day 1? Diameter is also a chord. So does everyone see that diameter right there, which is also the chord? Do they intersect? Yes, okay. Name two pieces of the pink chord. Okay, so I know the product of 8 and 10, and now here's where it gets a little crazy. The diameter is also intersected too. The diameter is split up into what and what? Well, it's definitely split up into x and, oh boy, now I got to find how long that piece is. Everyone agree with me? Because it's x times whatever that piece is right there. Woo, whoo, whoo. And that's why I gave you this random 12. What's the 12, Lauren? Radius, right? Which would make the diameter how long? So this whole diameter is 24. That piece is x. This piece is... Nice job. Everyone see here. 8 times 10, the product of those two segments, again, on the diameter. X times the rest of it. Everyone okay on where the 24 minus x comes from? All right, let's roll. 80 equals 24x minus x squared. Uh-oh. Uh-oh, start crying. Tissues on my desk if you need them, because what are you going to have to end up doing here? Oh, my aching heart, honors kids factoring. Lauren, you're off the hook. Thanks. 16? Who's 16? All right, I'm just telling you there, Rico Suave, that I refuse to do quadratic formula.
All right.
So how do you want to start factoring?
Well, first we could take the x squared and break that up. So we have 2 x's.
What? What do you want to move over?
On x squared and 24x.
Yeah, I know. Yep, good. I don't want to move the 80 over because I get heartburn when I have to do a negative x squared. All right, so let's move everything over. So you get x squared minus 24x plus 80 equals 0. And now we're looking for two numbers that multiply to what up here, Andrew? 80 and add 2.
24.
Yep. Oh boy, everybody. This should be good. It's such a large number. Anybody hit those numbers? Laura, Joanna? 20 and 4. Negative, negative. So we do get two answers out, x equals 20 and x equals 4. We're not going by the looks of the diagram. All right, I don't want to just pick 4 because it's the smaller part there. All right, could be 20, could be 4. Anyone I should reject because it's negative? No, there's nothing, no reason to reject any, so I'm going to accept both. Unless this problem specifically comes out and tells me that this part, this part bigger than this part, I got to accept both. Okay? Questions about that? Yes, Matt, go ahead. I'm ready for it. I'm good. I'm glad if somebody's challenging me right now.
Wouldn't the side with the x be 12 minus x? 12 minus 20.
Say that again.
Because it's a radius, and then x is like taking up part. So it would be 12 minus x.
So you're saying because we called this part 24 minus x, this part right here?
Like I get the but it's also like let's take it like as like a radius. So then wouldn't it be 12 minus x for that little part there?
Okay, ready? Here's what I think Matt's getting to. How long is the radius? The radius is 12, right? So if I called that piece 4, that doesn't make any sense. Does everyone see it? Because if I call this piece 20, everyone see when I'm talking, if I called this piece 20, this piece would be 4. Everyone would agree? Is that even humanly possible for that piece to be 4 when the radius is already 12? No, so I have to end up rejecting something. Do we see that? Or you want me to go over it one more time here? If you call x 20, if x is 20, what's this piece here then? 4. How can that be 4 when the radius is 12? Everyone agree with me? Yes? No? Talk to me here, yeah? Okay, so I have to reject x to be 20, so x will end up being 4. Thank you, Matt, for challenging. All right. You get a fresh cut too?
No, I got it.
Oh, sorry. Professional?
Yeah.
Do you like it? Or is it too short? Okay. You challenging your group mate there? Is that the issue? Because that's not bad. That flow's not bad, right? Matt's flow? All right, that's not bad. Okay. Other questions? Jack, I hope you're next, bud, because I think I just saw a bird pop out there of that nest. All right. 3, everyone ready? And ladies, don't get offended. I just don't I don't cross that line with the ladies' haircut. Sorry. All right. If any of you ladies have fresh cuts, I don't go that way. All right. Because I don't know what's good, what's bad. I don't want to offend anybody, so I stay way, way away from that. Okay. Like I come home and my wife goes, "Don't you like my new haircut?" And it's like I could barely tell. What'd you get? Like an inch cut off? Yeah, it looks beautiful. Great job. All right. All right, find the length of the chord CD if it is 3 centimeters from the center. All right, so it's the chord 3 centimeters from the center. Radius is 5. All right, so radius of this circle is 5. Find the length of CD. Anybody want to apply a circle theorem right now that's happening? Apply a circle theorem that's happening right now. Diameter perpendicular to a chord. What's happening to chord CD, Madeline? It's being bisected, right? So these two pieces right here are going to be congruent. So we can start up by calling both pieces x and x, since they're the same. Number 3, name a chord up here. Just name it with the letters. Name one chord in the diagram.
Oh, A.
AB, it's a diameter, so it's also a chord. Got it? Okay, I need somebody's help. What's it split into? 13. Who's got 13? Okay, right here. It's split into, ready? How long is that piece? 8 times the other piece. Can we find that piece? Why 2? Its radius is 5. That piece is 3. So this piece right here has to be 2. Do you see what I mean, guys, by the diameters being cut by CD into a piece of 8 and 2? We see that. We see that. Yes? Okay. Name the other chord in that diagram. 22. Name the other chord. CD. And it's being broken up into what pieces? X and X. Segment times segment. Go to the other chords equals segment times segment. 16 equals x squared. X equals plus or minus 4, right? But why don't I only care about the minus 4? I can't have a negative side length, so I only care about the positive 4. Didn't answer the question, though. Why didn't I answer the question? 11, help me out. I didn't answer the question. So what am I doing with 4? Which would be 8. Thank you. Nate, you see all that? Hi, how you doing? Mr. Carlino, good to see you. We all right? This kid. Oh, no diagram. Looks like we're going to have to draw our own, huh, kids? I have chords AB and RS intersect at point E. Go ahead. Doesn't matter how it looks. Just draw 2 chords, AB, RS, intersect at E. Ooh, hey, what do you guys put in at RE and ES? If it's a ratio of 3 to 4, what do you guys put in there? RE you're labeling as 3x, and ES you're labeling as 4x. All right, let's get to work. '21, name a chord up here. AB, it's split into 2 segments of what? Okay, 3 times 16 equals, name the other chord in the diagram. 23, name the other chord. RS, and it's being broken up into? So their products are equal. I got 48 equal to, oh boy, if anybody right now is writing down 7x or 7x squared, please leave the room immediately. All right, and preferably don't come back. 3x times 4x. 12x squared. I did get a 7x yesterday. Suggestions on what you want to do from here. 3, what do you want to do from here?
Divide by 12.
Nice job. Divide by 12, so I get x squared equal to 4. Take the square root of both sides, you get plus or minus 2. Do I care about the minus 2? Nope, because I'll make it a negative length, so I only care about 2. Go ahead, plug it back in, and let me know what RE and ES would be equal to. When you're ready, 20, let me know. 6, ES, 8. Yep. Okay, I'm going right to the bell here. Questions about that one? All right, last little theorem here. Since we're talking about chords today, if the chords are parallel, the arcs in between are congruent. All right, so if the chords are parallel, the arcs in between are congruent. So let's see if we can at least fit one example in here. I think we can. Circle O, AB is parallel to CD. 2 chords are parallel. Name the arcs that should be congruent up here then. Name the arcs. If CD and AB are parallel. Whoa, oh boy, rattled. Here we go, come on. 10, name the arcs that should be congruent. 11, that's what I thought. Karma. CA and DB are congruent. The chords are parallel. The arcs that are formed are congruent. So if AB is 80, what's CD again? I'm going strong here to the bell. Stay with me. That's a diameter, so that tells me this arc here will be 180, right? I already have 80. How much is left over? 100 for these two arcs. So each arc has to be 50. All right, I'll be here today now. That homework and the review problems due on Monday.